Hello class, welcome to Chapter 13, Relay Pump Operations. In areas where municipal water supplies are not readily available or static water supplies are not available close to the incident, the IC must establish a plan to obtain an uninterrupted water supply through a relay pumping operation, a tanker shuttle, or a nurse tanker operation. These operations can be labor and equipment intensive. Appointing a water supply officer to oversee them will ease the burden on the IC. This chapter provides detail on what a source pumper is responsible for, the equipment necessary in a relay pump operation, and how to safely shut down the relay pump operation. The knowledge objective that we're going to cover in this class is to describe relay pump operations. Establishing an uninterrupted water supply is one of the most important objectives for any incident commander, or IC. In areas where municipal water supplies are not readily available or static water supplies are not available close to the incident, the IC must establish a plan to obtain an uninterrupted water supply. An uninterrupted water supply can be obtained through a relay pumping operation, a tanker shuttle, or a nurse tanker operation. Again, as I mentioned earlier, these operations can be labor and equipment intensive. Appointing a water supply officer to oversee them will ease the burden on the IC. A relay pumping operation can be one of the most complex of these options because it requires at least two pumpers and sometimes multiple pumpers to form a relay system, and this is shown in figure 13-1 in your text. Water is pumped from a water source, hydrant or static, through hose under pressure to the apparatus engaged in fire suppression efforts. Relay operations can be as simple as one fire pumper at a pond or lake and the other fire pumper at the fire scene, or as complex as the use of multiple pumpers to supply water over long distances to a fire operation. Let's discuss the components of a relay pumping operation. To establish any type of relay, you must have a minimum of 2 fire pumpers, hose lines, and personnel. One fire pumper is located at a water source. This is called the source pumper. The other fire pumper is positioned at the fire scene, and this is called the attack pumper. Any other fire pumpers that are between these two apparatus and are positioned to maintain flow pressure in the relay system are called relay pumpers. 2 medium-size or large diameter hose lines are used to supply water in this scenario. Relay pumping operations will demand the use of personnel as they are being established, especially at the source pumper. Once the relay is established, generally the only crew member who needs to remain with the fire apparatus is the driver-operator, as long as the area around the fire apparatus is safe from traffic flow. If it is not, a second member should be left behind to assist the driver-operator. All other crew members should be used as resources if the IC chooses to do so. The source pumper is the most important pumper in a relay because it is located at the water source and supplies water to the entire fire incident. This is shown in figure 13-2. The source of the water is either a fire hydrant or a static water source. The source pumper should consist of the largest fire pump of the units assigned to the relay pumping operation, thereby ensuring that it can provide the maximum amount of water. For example, if the source pumper has a 1,500 gallon per minute pump, it should be supplying the 1,000 gallon per minute pump on the relay pumper. This setup ensures that the 1,000 gallon per minute pump can be supplied with enough volume of water to meet its capacity if needed. If the reverse were to be true, then the larger pump could not be supplied to capacity because the incoming flow would be less than 1,500 gallons per minute. The attack pumper is usually the first unit at the scene of an incident. Its operation will dictate how much water will be needed based on how many gallons per minute the fire attack requires. If the attack pumper cannot establish its own water supply, it may lay a dry supply line into the scene to be filled later by a source pumper or a relay pumper, as shown in Figure 13-3. If the attack pumper is being positioned in an area that has limited access, it is generally recommended that a supply line be laid down from an open area to the limited access point. Another responding engine should then complete the connection and provide a water supply to the attack pumper. Upon its arrival at the incident, the attack pumper will start supplying hose lines while operating from its water tank. It will then switch over to the relay supply line when it's ready. This process presents a challenge to both the driver-operator and the IC. The fire attack is initially limited by the capacity of the attack pumper's water tank. The attack pumper will be able to support additional hose lines only if the incoming water supply from the relay operation will support them. For example, if the relay operation is supplying 300 gallons per minute of water, the attack pumper will be able to provide slightly less than 300 gallons per minute of discharge flow to the hose lines. The amount of flow available is valuable information for the IC and must be identified so that the IC can make tactical adjustments to the overall strategy until water supply can be improved. Ultimately, the attack pumper serves as the quote-unquote workhorse at the incident, as it provides water to all of the hose lines that are attacking the fire. If the attack pumper does not have water, then no attack on the fire can take place. Relay pumpers are the fire apparatus that are placed in the middle of the relay pumping operation, as shown in Figure 13-4. They obtain their water from the source pumper and increase the pressure to the next fire pumper in the relay. These pumpers act like booster pumps to maintain pressure throughout the length of the relay. A relay pumper cannot increase the volume of water being pumped. It can only increase the pressure because the source pumper provides the flow quantity based on the volume being discharged by the attack pumper. For example, if the source pumper is flowing 800 GPM or gallons per minute at 80 psi, the relay pumper will receive a flow of 800 GPM, but due to friction loss in the hose lines, the water will be at a pressure of only 50 psi. The relay pumper will increase the pressure back to 80 psi and continue to flow at 800 GPM to the next pumper, which will then increase the pressure again to overcome the friction loss until ultimately the 800 GPM flow reaches the attack pumper. Let's talk about equipment for relay pumping operations. Fire hose is the primary path of travel for water to get from the fire pumper to another in a relay operation. The hose can consist of single large diameter hose, which is 4, 5, or 6 inches in diameter, or multiple medium-sized hoses, which are 2.5 or 3 inches in diameter. Single lines of LDH, by their design, have a very low friction loss variable, 7 psi, when flowing 1,000 gallons per minute in a 5-inch hose line. Compare this to a single 3-inch medium hose line, which has a friction loss variable of 21 psi per 100 feet for just 500 gallons per minute. Let me say that one more time. Compare this to a 3-inch medium-sized hose line, which has a friction variable loss of 21 psi per 100 feet for just 500 gallons per minute. To overcome the higher friction loss associated with use of medium-sized hose lines, as I was just discussing, it is recommended to use 2 hoses for a water supply. To avoid this issue altogether, it is highly recommended that LDH be used whenever possible. To determine the friction loss for a relay pumping operation, you must know A, how much fire hose is in the part of the relay that you are supporting once it is established, B, the gallons per minute, and C, the elevation. You can then calculate the friction loss for your part of the relay operation and adjust your discharge pressure accordingly. Relay pumping operations may require some other standard equipment, such as hose adapters to connect hoses with different types of threads, a Siamese hose which merges two medium-sized hose lines into a single LDH, a manifold which splits a single LDH into 2 or 3 medium-sized hose lines, and reducers which connect larger single hose lines with smaller single hose lines. No matter which size hose you're using to supply water from the source pumper, each pumper in the relay operation and the attack pumper must be equipped with an intake relief valve. Most modern pumpers are equipped with these valves at the time they are built. Older pumpers may need to be retrofitted with external valves. An intake relief valve will prevent the incoming water supply from reaching excessively high pressure, which might damage the pump and possibly interrupt the relay operation. Relief valves discharge the excessive pressure through a port located on the valve. Personnel for relay pumping operations is what we're going to discuss now. A safe relay pumping operation requires that you have adequate personnel for the operation. A minimum of 2 crew members should be assigned to each fire pumper if the pumper will be exposed to moving traffic and other hazards around the fire apparatus. As the driver-operator, it is your responsibility to operate the pump and manage the intake and discharge pressures. The second firefighter is responsible for managing the area around the fire apparatus so as to ensure the safety of the members by monitoring vehicle movement around the fire pumper and warning you of possible dangers. Let's discuss preparing for a relay pumping operation. The length of a relay pumping operation is primarily determined by the distance between the water source and the incident. The amount of water required by the attack pumper and the size of the supply line can also affect whether a relay pumper is required and, if so, how many of these apparatus are needed. As discussed earlier, small diameter supply hose lines decrease the flow capacity and increase the friction loss. Generally, LDH represents the best option for relay pumping operations, as we discussed earlier as well. Given that supply hose is critical for successful relay pumping operation, it must be in place before water can be flowed. A forward lay is a supply hose line that is brought to the scene by a fire pumper from the water source, as shown in Figure 13-5. An engine that connects to a fire hydrant and then proceeds to the fire scene is an example of a forward lay. Hose can also be laid backward from the attack pumper to a water source or to another fire pumper in the relay line. Both of these are examples of a reverse lay technique, and this is shown here on your video and in Figure 13-6 in your text. Alternatively, one fire pumper may lay hose into the scene while another fire pumper lays hose out from the first engine's coupling to the water source. This approach is called a split lay and is shown in Figure 13-7. Another type of split lay involves laying a line from an open area to the pumper where there is limited access and having a second pumper connect that hose and move to the water source. Once you have the hose in place for the relay, you can determine whether a relay pumper is needed by calculating the amount of friction loss for the length of the hose in the hose lay. If the discharge pressure will exceed 80 psi for LDH or 175 psi for medium-sized hoses, a relay pumper is needed to boost the water pressure. Although a good rule of thumb is that no relay operation should extend for more than 800 feet, it can be longer as long as you keep adding pumpers. Maintaining relay operations over a shorter distance will keep the pump discharge pressure manageable while ensuring the proper quantity of water flows to the attack pumper. Keep in mind that the attack pumper's needs are the deciding factor in terms of the pressure and flow necessary. Adapters, reducers, manifolds, and appliances may also be used in relay pumping operations. When two fire pumpers use different threads on their couplings for hose, adapters allow for both pumpers to connect to the same hose. When the size of the hose lines differ, reducers are needed to connect the mismatched lines together. Manifolds greatly increase the effectiveness of relays by allowing one LDH to supply two 4 medium-sized hose lines with water. When an LDH is split into multiple hose lines in this way, however, the overall friction loss increases due to the compression of the water back into smaller vessels, in addition to the flow restrictions within the appliance itself. An appliance is any other component that you can flow water through. The Siamese hose and manifold are examples of appliances that, when used in a relay pumping operation, must be taken into account when calculating the friction loss. Now let's discuss calculating friction loss. As stated earlier, the attack pumper's needs drive the relay pumping operation. For this reason, the attack pumper's driver operator must communicate to the source pumper's driver operator how much water in gallons per minute is flowing now or is planned to flow. The attack pumper driver operator can determine his or her flow quickly by adding together the flow of each hose line or master stream that the attack pumper is discharging. For example, if the attack pumper were flowing at 500 gallons per minute from 3 hand lines, the driver operator would communicate to the source pumper that he or she needs 500 gallons per minute. The driver operator of the source pumper would then calculate the distance between the two pumpers in hose. For this example, assume that two lines of 3-inch hose are laid out over 400 feet. To calculate the friction loss, you would divide the flow in gallons per minute by the number of hose lines being used, 2 lines in this case. Each line will flow half of the water required. 500 gallons per minute divided by 2 equals 250 gallons per minute. A 3-inch hose line at that flow has a friction loss factor of 6 psi per 100 feet, which is multiplied times the number of feet in hundreds, 4 in this example, which gives a total friction loss of 24 psi. Once you have calculated the friction loss, you would add 20 psi for residual pressure to prevent cavitation, for a total discharge pressure of 44 psi. One type of relay pumping operation is called a calculated flow relay. It requires that the driver operator of the source pumper obtains from the attack pumper the flow required for fire operations. The driver operator must then calculate the friction loss for each hose layout in the relay and add 20 psi for residual pressure at the attack pumper. This type of relay is the most common. It uses actual flow calculations to determine the quantity of water required. Many fire departments have standardized the supply pressures that they use for constant pressure relays based on prior experience. The pumper driver operator in this type of relay sets the pump discharge pressure to 175 or 80 psi, depending on the size of the supply line, and maintains this pressure for the duration of the relay pumping operation. Setting the pressure relief valves or pressure governor will maintain the desired pressure in the event of any changes at the attack pumper and will prevent overpressurizing of hose lines or damage to the pump. The relay pumping operation starts at the source pumper and is where the largest fire pump should be located. The hose between the pumpers should be placed through either a forward, reverse, or split hose lay. LDH provides the highest efficiency for relay pumping operation. Once at the water source, the source pumper begins a drafting operation from a static water source or connects to a fire hydrant. Make sure to see Drafting from a Static Water Source skill drill in this chapter. And this chapter, of course, is titled Drafting and Water Source Operations. Now, when setting up a source pumper at a static water source, consider the maximum amount of water available for the operation. Once you've established the draft and water is flowing through the dump line, connect the hose lines to be supplied and notify the receiving driver operator that you are ready to start flowing water. To determine the gallons per minute needed, calculate the friction loss for the supply hose based on the gallons per minute rate to be supplied, the length of the relay, the size of the hose being used, plus a residual pressure of 20 psi. If the next pumper is not ready, then wait until it is set up before initiating the flow. If you are supplying the attack pumper, advise the driver operator that you are ready to begin flowing water. The attack pumper crew will then let you know when to send the water. Whether you are supplying the next pumper in a relay operation or the attack pumper, the order of the steps remains the same. Open the corresponding discharge valve and slowly begin flowing water while simultaneously advancing the throttle as you are opening the discharge valve. You do not want to lose the draft of the pump, i.e., interfere with the pump's vacuum strength, by flowing more water out than is being supplied to the pump. When you reach the desired pressure, set the pressure relief valve or the pressure governor to prevent damage to your pump if the flow is stopped or interrupted by a relay pumper or the attack pumper. Establishing a relay pumping operation from a hydrant works in the same way as using a hydrant as a source of water to your own supply. The only difference is that you are supplying another pumper and not the hand lines attacking the fire itself. Select a suitable hydrant that is as close to the incident site as possible. Make sure to flush the hydrant before connecting it with a soft suction supply hose line or LDH. If neither of these types of hose is available, you can connect to the hydrant using two medium-sized hose lines to establish a water supply. Contact the receiving driver operator to notify him or her that you are ready to start supplying water. If the next pumper is not ready, wait until it is set up before you begin to flow the water. If you are supplying the attack pumper, advise the driver operator you're ready to begin the flow, and the attack pumper crew will then tell you when to send the water. Fill the supply lines slowly by opening the discharge valves. Advance the throttle to the desired pressure, calculated or constant, and monitor the residual pressure from the hydrant. Set the pressure relief valve or the pressure governor to prevent damage to your pump if the flow is stopped or interrupted by a relay pumper or the attack pumper. Now let's talk about operating the attack pumper. The attack pumper is generally the first pumping apparatus to arrive on the scene of a fire. It establishes the hose lines that attack the fire. For example, two 1 3/4 inch hose lines flowing at 100 GPM each, requiring a total water flow of 200 GPM from the pumper. If you start and continue flowing water from the tank or the fire pumper until the relay operation is set up, you will have to monitor your tank level closely to ensure that interior fire crews do not run out of water. Most fire pumpers have 500 to 1,000 gallons water tanks. These allow them to supply the two 1 3/4 inch hose lines for 2.5 to 5 minutes before running out of water. Getting the water from the source pumper, whether directly or through a relay, is critical to continued operations and firefighter safety. Once the supply lines are charged, bleed off the air in the hose line from the bleeder valve located at the pumper's intake valve until a steady stream of water comes out of the bleeder. This is shown in Figure 13-8. This air is present as a result of the hose being filled with water. The water displaces this air as it flows through the hose, with the air being forced to the end of the line. So it's always a good practice to bleed your supply lines, because this action prevents air from entering the pump and causing it to cavitate. The longer the hose length, the more air will be displaced. Slowly open the intake valve while backing down the throttle until the intake valve for the supply line is fully open. The pressure from the incoming water supply will increase the discharge pressure to the hose lines unless you decrease the throttle rate. The tank-to-pump valve should then be closed in older apparatus, but can remain open in newer pumps because of a check valve. Then slowly open the tank fill valve. This action will prevent the pump from creating a vacuum in the tank and drawing air into the pump through the open valve into a tank containing little or no water. Open the tank fill valve to only a slight extent. Creating too large an opening will take away most of the incoming pressure so that the hand lines will not receive the required pressure and flow. Fill the tank on the attack pumper, and then when it is full, close the tank fill valve. From this point forward, the attack pumper will be running solely off of the relay or source pumper or pumpers. Advise the source pumper of how much water you need and indicate whether the incoming pressure is sufficient to maintain at least 20 psi of residual pressure. If you need more flow, contact the personnel providing the supply quickly to communicate your needs. Do not try to flow more water than the source pumper is supplying, as this will cause your own fire pump to cavitate. It is important to notify crews operating those lines of the situation so they can make tactical adjustments or retreat to a safe location until water supply issues are resolved. Now let's discuss operating the relay pumper. The operation of the relay pumper can be quite simple. All you are doing is laying out hose between the next pumper and your location and then supplying the required pressure and volume to the next pumper in line or to the attack pumper. A relay pumper will receive its supply from the source pumper or another relay pumper depending on the distance between the water source and the attack pumper. If you participate in establishing the relay operation, you will need to provide hose to the receiving pumper, another relay pumper, or the attack pumper through a forward, reverse, or split hose lay. Remember that LDH is the most efficient choice of hose for relay pumping operations. You will need to calculate the friction loss for the supply hose based on the flow rate to be supplied, the length of the relay, the size of the hose being used, plus a residual pressure of 20 psi. Once the hose is in place, the source pumper will contact you to advise that water flow is ready to start. A relay pumper is considered ready when the supply hose to the pumper and the discharge hose to the next pumper are connected. When the water fills the supply hose, you should bleed off the air in the hose line from the bleeder valve located on your pumper's intake valve until a steady stream of water comes out of the bleeder. Remember, your supply line will contain more air if the hose lay is long. Slowly open the intake valve to allow water to enter the pump. The tank-to-pump valve on your apparatus should be closed, and the pump recirculating valve should be open. This will help prevent the pump from overheating until you start flowing large quantities of water. Open the discharge valve or valves for the corresponding discharge port or ports to begin flowing water. Adjust the throttle to increase the flow to the desired pressure based on your calculations for friction loss or the predetermined pressure for the relay. Monitor the incoming residual pressure from either the source pumper or another relay pumper. Your goal is to maintain 20 psi of residual pressure. To increase the residual pressure, you can either contact the source pumper to request an increase in pressure or decrease your own flow pressure, which may negatively affect the line supplied by the attack pumper. If the flow or pressure to the attack pumper is ever effective, you must communicate that fact to the driver operator of the source flow pumper immediately. Let me say that one more time. This is really important. If the flow or pressure to the attack pumper is ever affected, you must communicate that fact to the driver operator of the source pumper immediately. Once the flow is stabilized, set the pressure relief valve or the pressure governor to prevent damage to the fire pump if the flow is stopped or interrupted by either the supply or discharge side of the pump. Remember that you are part of a relay operation and therefore are affected by the actions of others supplying your pumper or those receiving your supply. Depending on the nature of the relay pumping operation, the last pumper in the series may supply 2 attack pumpers. If this is the case, then the last pumper may use a manifold. That is, one LDH that is split into 4 or 5 medium-sized hose lines that provide water supply for multiple attack pumpers, and this is shown in Figure 13-9. To use the manifold as one option in a relay pumping operation, the last relay pumper would provide a supply line to the manifold via the LDH from a discharge port. If 2 attack pumpers are being used at different locations within the incident, each can be supplied with 2 medium-sized hose lines through the manifold. Once the medium-sized hose lines have been attached, contact the attack pumpers to advise them that you are ready to flow water. At that point, the valves on the manifold can be opened to start the flow of water. The pumper supplying the manifold will need to account for the additional friction loss of the appliance plus the residual pressure for the attack pumpers to maintain the correct pump discharge pressure. Let's talk about joining an existing relay pumping operation. Most relay pumping operations are completely set up at the beginning of the incident because adding a pumper to an existing relay operation usually requires that the flow of water be stopped. Depending on the size of the relay pumping operation, this step can involve a number of pumpers. If you are called to assist with a relay pumping operation and your fire apparatus is not part of the initial setup of the relay, then you need to be able to hook up your pumper to the hose lines that are already in use. Pumpers that are generally added to an existing relay pumping operation occur when there's not enough pressure or flow to meet the demands of the attack pumper at the scene. Many fire departments that regularly use relay pumping operations because of issues related to limited water supply will use a relay valve in long hose lays. This is shown in Figure 13-10. A relay valve lets you hook up into the relay without shutting down the entire relay operation. With this approach, you simply hook up both the supply line and the discharge to your fire apparatus before opening this relay valve, as shown in Figure 13-11. Slowly open your intake valve on your fire apparatus to obtain a water supply. Once the valve is completely open, slowly open the discharge valve from your pump to the hose line that is connected to the relay valve. Observe the incoming supply pressure and increase the discharge pressure to provide the GPM and pressure required by the attack pumper. Monitor the incoming pressure to maintain 20 psi of residual pressure. Set the pressure relief valve on the pressure governor to prevent damage to your pump if the flow is stopped or interrupted. If a relay valve is not present or has not been used, then the task of hooking into an existing relay operation is more complex. If you must hook into an existing relay, get all of your equipment ready and place your fire apparatus in the proper position. Once you have calculated the required discharge pressure based on the length of your hose lay, advise command or the water supply officer and the attack pumper that you are ready to hook into the relay. The source pumper and any other relay pumpers in the supply line will then shut down their supply lines while the attack pumper switches from the supply line of the relay to tank water. Attach the incoming line from the source or other relay pumper to your intake valve first, and then attach the discharge line to the discharge valve. Contact the source pumper and inform its crew that you're ready for water and bleed off the air in the line as this flow enters the intake valve. Contact the next pumper in the relay or the attack pumper to advise its crew that you are flowing water again and increase the discharge pressure to meet the required GPM and pressure flow. After you have water flowing, set the relief valve or GPM needed to prevent any sudden surges. Now let's talk about pressure fluctuations in a relay pumping operation. The needs and capacity of the attack pumper affect all of the other fire pumpers in the relay operation. The driver operator of the attack pumper determines the GPM needed and notifies the driver operator or operators of the relay and or source pumpers of its supply requirements. Unfortunately, should something change suddenly, there may not be time to communicate the need to modify the flow to the operator. Mechanical failures or an increase or decrease in hose line flows, for example, can cause pressure fluctuations. These generally do not have a large effect on the operation and can be handled by the pressure relief valves or the pressure governor. At other times, you must manually adjust pump pressures. During an operation, if the attack pumper were flowing 500 GPM and a 200 GPM nozzle was shut down, all of the pumpers in the relay would see a sudden increase in pressure. This event should not be a concern unless pressure fluctuation is greater than 200 psi, which is a magnitude of change that could cause hose line failures or pump damage. In such a scenario, the driver operator of the attack pumper would need to decrease the pump discharge pressure, and each pumper in the relay would then need to do the same. Should the attack pumper open an additional line that results in an increase of flow, all pumpers in the relay will need to ensure that their supply lines do not drop below 20 psi residual pressure to avoid pump cavitation by simply advancing the pump throttle to increase the discharge pressure. Now let's talk about shutting down a relay pumping operation. The order to terminate or shut down a relay pumping operation is given by the IC or water supply officer only after careful consideration. Relays are difficult to establish and once in place should be maintained as long as necessary. Shutting down a relay pump operation is a simple process, but all pumpers participating in the operation must act in a coordinated fashion. When shutting down a relay pumping operation, the attack pumper acts first. The driver operator of the attack pumper must ensure that the tank of the fire apparatus is full and then slowly throttle down. It is important to keep the hose lines flowing water while you shut down a relay. This prevents fluctuations in water pressure throughout the entire relay pumping operation. The next pumper in the relay then makes sure that its tank is full and slowly throttles down while still flowing water. This sequence continues until all pumpers have completed this step, ensuring that their tanks are full. When the source pumper is reached, it contacts the attack pumper to begin closing the intake valve. All pumpers in the relay that begin closing the intake valve and discharge lines until all pumpers are no longer flowing water, including the dump line from the source pumper itself. The hose lines can then be disconnected and drained before being reloaded or rolled up. This systematic approach to terminating a relay pumping operation prevents pump damage by keeping the water flowing at low levels before it is finally shut down completely. The source pumper can then close the hydrant to stop the flow of water into this pump. Alternatively, if it is providing water from a static water source, simply stopping the flow of water through the pump will break the vacuum and draft of the pump. This action will stop the flow of water through the hard suction hose into the pump. If that interruption does not occur immediately, disengage the pump, remove a cap from an unused discharge port, and open the valve. This move should allow the water to drain back through the hard suction hose line and back into the static water source. The setup steps are simply reversed. All equipment and hoses are placed back into the fire apparatus, and the pumper is ready to return to service. Let's discuss safety for relay pumping operations. Safety is the utmost concern in any operation, obviously, but it cannot be overlooked when conducting relay pumping operations. It is an understatement to say that water is critical to the success of any firefighting operation. In areas where uninterrupted water source is not available and must be established, knowing where and how you will obtain water starts with planning before the incident begins. Identifying large static water sources, dry hydrants, or potential drafting sites before an incident occurs will help improve the efficiency of the incident response. Incident safety is improved when crew members have the appropriate training, knowledge of how the equipment works, and practice in using it. For example, which equipment does your company have available? Which appliances are needed for this type of operation? And do your crew members know how to use all of the equipment and appliances? Make sure you fully understand the role played by each position within a relay pumping operation and practice those roles regularly. An effective driver operator will know which equipment he or she will need to use to provide water to the scene of a fire through a relay pumping operation. Communication is another area that must be addressed as part of any relay pumping operation. Contact the IC for a tactical channel to which all pump operators can be assigned. With this communication setup, all pump operators can talk to one another directly when making requests for additional water or other pressure adjustments without distracting the fire attack operations personnel who are communicating on the main tactical channel. Constant communication between pump driver operators will help prevent situations that might otherwise cause pump damage. Fire hose is another source of safety concern during a relay pumping operation. Watch for any signs of damage to or possible trouble with the hose. If a catastrophic failure were to occur in the hose lines of a relay pumping operation, the safety of the firefighters on the hand lines at the fire scene will be compromised. If you can identify defects and replace the hose section before it is used, you will save time later and have a safer operation. If you do see a defect after operation has begun, simply get the replacement hose in place and follow the shutdown procedures used for entering or exiting a relay pumping operation, in which the attack pumper switches to tank water before stopping the flow of water from the relay. The pump driver operator is at risk for injury if he or she is not wearing some type of protective gear. At a minimum, personnel should wear turnout pants and boots, a helmet, and gloves. This PPE will protect the driver operator's hands, feet, and head from injury caused by falling equipment or catastrophic failure of a hose line. If crew members will be operating in or around the street and moving traffic, they must wear reflective vests as well, even during daytime operations. In summary, establishing an uninterrupted water supply is one of the most important objectives for any IC. Having a sustainable water supply is a vital part of any fire incident scene. A relay pump operation consists of at least 2 relay pumpers, and the source pumper is located at the water source. The attack pumper is located at the fire scene. The relay pumpers are placed between the source and attack pumpers. A relay pump operation may be completed with LDH or multiple medium-sized hoses. Various hose lays may be used to lay the hose between pumpers. 2 basic types of hose relay pumping operations are calculated flow and constant pressure relay. Relay valves may be used so that the pumping operation does not have to be shut down when a new pumper hooks into the system. And constant communication between driver operators is necessary for a safe operation. Class, thank you for your time and attention in discussing relay operations. We'll see you next chapter. If you have any issues, you can email Chief Breakville or give him a call. Again, thank you for your time and attention, and we'll see you next chapter.